Hello, everyone. It's a great pleasure to join this meeting. I'd like to thank for the invitation to give out recent data on epithelial barrier theory. I'm going to talk about the epithelial barrier theory, which is together with the global health crisis, because the number of patients in our hospitals significantly increased during the last 60 years, and during the last 20 years, this increase is very visible. My talk will have first the introduction of type 2 response. What is a type 2 response? I'd like to talk to you about it first. Then I'll talk about the environment crisis starting and continuously growing after 1960s, diseases linked to epithelial barrier damage, and mechanisms of the epithelial barrier theory and biomarkers of barrier leakiness. Major threats to humanity and nature of the world is very important, and these are happening simultaneously and very strongly affecting our future. We are talking about global warming and climate change, which is a very major problem, of course. Then the talk today is about global environment health crisis, exposure to toxic substances in our environment, and increased number of patients in all areas. And I'm going to talk about mainly a climate change, which is happening in our environment and in our body. And the third point is infections and antibiotic resistance, which is very important for the future of humanity. But the most important thing, and which is linked to all of these, is the ignorance and anti-science group and mentalities. Ignorance is in the public, but ignorance is also taking place in the politicians. So if you look at the origins of type 2 response, first, I would like to now discuss with you the parasitic infections and how type 2 response is important in parasitic infections and it's life-saving. And we will go now here 90 years back to Zurich University Parasitology Department, and we discussed the mechanisms of Ascaris, schistosoma, and hookworms. And when the infective eggs are swallowed in the model of Ascaris, they reach to intestine and then they hatch. The hatching eggs become larvae, and the larvae migrate to liver. And the larvae in the liver are at the size of 0.5 to 1 millimeter. They are quite small. But then they migrate to the lungs. They go to the lungs through normal circulation, vena cava inferior, right atrium, right ventricular pulmonary artery, and when they come to the lungs, they start an eosinophilic pneumonia in the lungs. This is called the Loeffler's pneumonia, described 90 years ago. And Loeffler's pneumonia is an eosinophilic type 2 pneumonia, and the reason for this pneumonia is the larvae which came to the lungs are at the size of 0.5 to 1 millimeter, but if they get adults inside the lungs, the adults will be 10, 15, 20 centimeters, and this will be killing. So every single larva should be expulsed from the lungs, and this is a very important response. So the main reason for the type 2 response here, including Th2 cells, innate lymphoid cells, cytokines, interleukin-4, interleukin-13, interleukin-5, interleukin-33, is to expulse this larva, to throw all of them outside the lungs, and to avoid that the Ascaris or schistosoma or hookworms do not grow inside the lungs. So after this eosinophilic pneumonia, they are expulsed and they get mixed up with the sputum. Then they are ingested again, and they are swallowed, and then they go to the intestines and they find a suitable place to grow adult. So if it doesn't happen, we see this very graphic picture, which is a killing thing. When these Ascaris grow in the lungs, it will be occluding all the bronchial tree. Now here is a skin example of this parasitic infections. This is scabies. Sarcoptes scabiei is the agent, and here this is the cover of our journal, and we can see here that this scabies is also causing an eosinophilic dermatitis. So what happened after 1960s to cause the global health crisis is a very important point. We have 350,000 new substances that are introduced to human lives. We know it from these publications. You can just enter the DOE number and find this paper. This paper is very interesting, and it is very good to know this as humans, but we didn't know it actually. Many of you still don't know these things. And this is an inventory developed from 22 chemical inventories from 19 countries. And it is saying that 350,000 or more chemicals and mixtures of chemicals have been registered for production and use. And this is actually a huge number. And there is substantial differences across countries. And what happened is that about 70,000 of these compounds are not well described, and 50,000 are not even named. We don't know the chemical structure of these compounds. They were reported as confidential compounds, that a patent is ongoing, or the companies did not want to give information, but they entered our lives and they ended up as pollution. That's a very important thing. Now we also bring together this with this epidemics and the pandemics and the epidemiology of allergic diseases graph. We see here John Bostock in 1819, who described the first case of hay fever. And here we see Charles Blackley, who described the first 28 cases of hay fever. He also called it hay asthma in his paper. And Charles Blackley had 6 years to collect these 28 cases. The diseases started at that time, but they were not like a pandemic. So the prevalence continued to 1900 in the range of 1%, in 1961 to 2%. So the real pandemic size started in 1960s. You can see the numbers: 4.4%, 8.4%, 26%, 43%, and a very strong increase. So this was at the same time when these substances started to be increased, and until this time, in the beginning, Industrial Revolution, the railways were very important. And then the oil industry joined, and together with oil industry, chemistry industry joined. In 1960s, the chemistry industry was very, very important, leading force of the world economics. Afterwards, we had the computer and IT. But currently, you can easily guess that the health industry is the main leading force in the world. So we have the chronic non-communicable diseases. In 1960s, there was 20-30 million patients. Currently, there is 2 billion patients. So what happened after 2000 is a second wave of these diseases started. We have food allergy, eosinophilic esophagitis, drug hypersensitivity. Food allergy was existing before in small numbers, but after 2000s, we have huge numbers. Peanut anaphylaxis was not existing at all. It became a huge public health problem in the range of 1 to 4%. And eosinophilic esophagitis was also very rare. The first series was reported from our institute with 13 cases. And now it is like 0.5% prevalence, which affects around 400 million patients in the whole world. So this is a very important reality. Together with this, we are talking about a pandemic of allergic and asthma, and also autoimmune diseases are increasing in parallel. So the allergy and asthma pandemic, we have some evidence how it started. In 1960s, it was noticed that asthma suddenly increased in almost every age group in England. In 1961, asthma increased in Finnish soldiers from 65 to 80. There was tenfold increase in the number of hospitalizations of children with asthma in Australia, England, New Zealand, Canada, and the United States. And between 1971 and 1981, it was found that asthma increased by threefold in Swedish soldiers, especially in those who came from the cities. When East and West Germany were united, in the East Germany, the prevalence of allergic diseases, atopic dermatitis and asthma, was in the range of 1.5%, which increased to 10% within 5 to 10 years, and to the rates of the West Germany. So there's also another important point, a major shift in immune response to environmental substances after 1960s. There was almost no Ig and IgG response to allergens in 1970s and 1980s. This developed the ignorance hypothesis. Rolf Zinkernagel developed this hypothesis, and he was saying that we don't need to develop antibodies to environmental non-dangerous substances because they cannot induce a danger signal, and they cannot induce an inflammation or a disease because they cannot go to the lymphatic organs. So the danger hypothesis of Polly-Matzinger was in the same direction. But now we know that there's allergen-specific Ig and IgG response. After 2000s, Ig is approximately in around 40% of the population and 90% of the patients, and IgG is almost 100% at the age of 1 year against milk and egg in healthy population. So these are very important changes in human life. So we are working on epithelial barriers. Currently, it's better to understand what epithelial barriers is. Here is like lung mucosa. We see that at the very apical site, we see the epithelial barrier molecules are sealing the surface of the lung. And if these are the tight junctions, and there is 24 claudins, tricellulin and occludins, 24 claudins, tricellulin, that are playing an important role in sealing of the surface of the epithelium. So closed tight junctions means being preventive and protective against all the environmental agents, including allergens. Open tight junctions means if there is too much inflammation here, this inflammation should be drained, but at the same time, allergens, pollutants, toxins can go into deeper tissues. And here we look at closer to this area, the apical area that seals, even water cannot pass through. And we have here claudins, occludins, tricellins, making very strong covalent bonds. And this makes the surface of the epithelium. Why are we working on epithelial barrier theory? That's an important point. In 1998, we started with Axel Trautmann on epithelial cell death and the reasons for epithelial barrier disruption in skin, lungs, and sinuses, which was demonstrating the first mechanism of eczema and at the same time epithelial shedding from the lung bronchial mucosa or also from sinus mucosa. And at that time, we developed artificial skin equivalents. In 2006, we better understand the major functions of epithelial barrier, keep away functions like a physical barrier, laminar reticulars thickening, and IgA, wash away functions such as mucus, ciliary movement, barrier opening and drainage, and an expulsion response and suppression functions. And we understood between 2009 and until now that the immune system makes a very strong triangle with the epithelial barriers and microbiome, and T cells, type 2 innate lymphoid cells, and IL-13 play major roles in this. And we can also understand that environmental agents that are seen in this picture, like laundry and dishwasher detergents, surfactants, diesel exhaust, ozone, nanoparticles, enzymes and emulsifiers in processed food, shampoos and body cleaners, household cleaners, toothpaste, particulate matter, and microplastic damage the epithelial barriers. The epithelial cells are not touching each other. There is microbiome in between, and some of the microbiome has passed. This is a translocation of the microbiome, and the leaky barriers allow the passage of allergens, toxins, pollutants, microbiome, and opportunistic pathogens. And these agents show synergistic effect in breaking the epithelial barrier. We have to quote shortly here Paracelsus. Paracelsus was the pharmacist of Canton Schwyz in Switzerland, and he said, "Sola dosis facit venenum." That means the dose makes the poison. Everything can be poisonous if the doses are high enough, and there's no poison without the dose. So that's a very important concept to understand. And the substances that we are talking about, they all have a poisonous dose and they all have a non-toxic dose. So that's an important point. Now to start with, we will talk about detergents, surfactants, and type 2 response. Here, the main culprit is sodium lauryl sulfate. Sodium lauryl sulfate was discovered during the Second World War, was introduced to detergents in 1960s, and it became one of the main substances in detergents, in shampoos, household cleaners. I was looking at a detergent, it was containing about 5 to 10% sodium lauryl sulfate, and in household cleaners, we see it. In some toothpaste, there's 3% sodium lauryl sulfate, and cosmetics and skin cleansers, there's 0.5 to 2%. It can be extracted from house dust, pillows, and bed sheets. Now, this is an experiment that by Ming Wang that shows the laundry detergents, but similar experiments were done with also sodium lauryl sulfate. And we can see here 1 to 50,000 dilution causes a big regulation of the cellular mechanisms. And here is RNA sequencing, and the upregulated group of genes are lipid metabolism, oxidative stress, cell survival, and interleukin 33. And downregulated group is cell adhesion, extracellular matrix organization, and wound healing. The interpretation of these findings is that there is a chronic wound that tries to survive the cells, and main culprits are sodium lauryl sulfate and sodium dodecylbenzene sulfate. This is a very interesting, very exciting experiment by Hideaki Morita's group and Kenji Matsumoto from Tokyo University. And here, 4 drops of detergents are put in the nose of a mouse, 0.1 and 1%. And we can see here the control mouse, a very healthy, normal bronchial mucosa. You can see the 3 bronchus here. And here, there is a very severe mixed inflammation, eosinophilic and also neutrophilic inflammation. Total leukocytes increase with the increasing dose of detergent. Eosinophils are responding very strongly and with 1% of the detergent, and neutrophils are also increasing very, very strongly. Then it was possible to look at which cells are responding to this sodium, and we can see that innate lymphoid cells, mainly type 2 innate lymphoid cells, are responding. 44% are becoming positive for IL-13 is happening. Basophils and T cells are not responsible for this early response. And this is the resting condition. And in IL-5 making, type 2 innate lymphoid cells are 17%. So here we see the increase with detergent total leukocytes. Eosinophils are increasing and neutrophils are increasing. But if there is a REC2 and common gamma chain knockout that doesn't have any innate lymphoid cells, then we see there is no increase in eosinophils. So that's very important to show that innate lymphoid cells are responsible. Another important factor is IL-33. And here we can see with detergents, IL-33 staining in the mucosa very significantly. In the control, there's very few cells that are positive. And we have here an IL-33 knockout mouse, and we can see that IL-33 knockout mouse has a very significant decrease in eosinophilia. That was increasing by normally detergent exposure, but when IL-33 is negative, is not expressed in the mouse, then we can see that its eosinophils are showing very significant decrease. Now we have another important study from the Mayo Clinic group, detergents and sodium lauryl sulfate and the relationship with eosinophilic esophagitis. We said that eosinophilic esophagitis started to increase after 2000, and it came from very few cases to several 100 million cases. And we can see that esophageal barrier is broken by sodium lauryl sulfate. This is shown as sodium dodecyl sulfate. It's the same material with 5 microgram per ml doses. And we can see that IL-33 showed a very significant increase in the dose of 5 microgram per ml and 10 microgram per ml. And here we see in the mouse, a normal mouse esophagus, and we can see here sodium lauryl sulfate. This is 0.5%, and here it's a very significant eosinophilic inflammation with the thickening of smooth muscle, mucosal thickening, and also the lumen is full with stricture and fibrosis taking place, and there's a lot of eosinophils, and this eosinophilic infiltration and also lymphocytic infiltration is taking place very significantly. Then from here, we come to very shiny dishes. This is a study done in our group. We can see professional dishwashers. Professional dishwashers were introduced to our lives after 2000, and laundry, normal laundry, and also household dishwashers were introduced earlier in 1960s. Professional dishwashers have a rinse aid, which contains alcohol ethoxylates, and Ismail earlier did these studies showing that up to 20,000 times dilution, the cells, these are the gut also epithelial cells, and they are dead, and in 40,000 dilution unexposed, we can see that the cells are alive, and the rinse aid is responsible for the cell death. Detergent itself is not. And here they were able to isolate these detergents from the cutlery, dishes, and glasses, and show that there is a cytotoxicity in 1 to 2 dilution, 1 to 5 dilution, 1 to 10 dilution, more than unexposed. So they were able to show that this extracted detergents from the cutlery and glasses and also plates was causing very significant decrease in transepithelial resistance. That means the barrier was opening, and this is also shown by passage of the FITC labeled dextran in 1 to 2, 1 to 5 doses. This is the cover of our journal about also eating and habits are changing in our life. I'll talk about now packaged food, mainly emulsifiers, preservatives, and surfactants. And packaged food became a very important way of feeding in our lives, mainly in the last 20 years. And before 20 years, the shelf life of packaged food was around 1 week in the big markets in Switzerland. And now the shelf life of packaged food is up to 6 months to 1 year. The commercial aim was to extend the shelf life and prevent the separation of the liquids. And it was successfully achieved from the commercial point of view, and shelf life was increased by several months. The mechanism and the aim here is to add the preservatives and emulsifiers to kill fungal growth and bacteria and provide a thickening effect. We asked them the question, is it possible to do this without harming human cells? Is it possible to use these preservatives which have antibiotic effects or emulsifiers which keeps the water inside? No, it is not possible. It's practically impossible. So Ismail, again, with our group in the epithelial barrier research, focus on the commonly used emulsifiers, two of them, P20, polysorbate 20, and polysorbate 80. Polysorbates are twins that if you are doing gel electrophoresis, you are using twins very commonly. And twins are very soapy, very toxic, and we can see here that the toxicity goes down to 0.1%. But very excitingly and very interestingly, 1% of these polysorbates are allowed in the ice creams and pastry in the United States. This is a huge public health problem, of course. And in Switzerland, you cannot use polysorbate in ice creams, but you can import ice creams from Denmark or from United States and sell them in Switzerland, which contain 1% polysorbate. So here's a big, long list of emulsifiers. And we can see that there's many of them, and you can read the packages and labels of the packages. You can see that there's a long list of emulsifiers, and currently we are working on all of them. So if we are talking about opening of the tight junction barriers, here we can see from the apical side, from the top, that the barrier is sealed. This is a closed tight junction barrier, very significantly. And this is an open tight junction barrier, which we first showed in 2010 by Maciej Chalubinski. We published all these data and several papers came, around 60 papers came from our group about the epithelial barrier hypothesis and theory, and you can go through. And one of the important things for you to know is that there's comorbidities and multimorbidities have also increased during the time, and they are also linked to epithelial barrier diseases. So the epithelial barrier theory is still one of the most prevalent theory to discuss, and we are talking about increased prevalence after 1960s and 2000s. And when we select diseases, we can find now up to 40 diseases that fulfill all these 4 criteria. The second criteria is microbial dysbiosis with loss of commensals and colonization of opportunistic pathogens. Circulating microinflammation is a new term that we are introducing. And epithelial barrier defect and epithelitis. Epithelitis is also a new term that when we are exposed to environmental substances, toxic substances, epithelitis is the initiator of this disease. Here is a list of diseases. These are the ones that the affected tissues have epithelial barrier problem. You can see here atopic dermatitis, asthma, chronic rhinosinusitis, allergic rhinitis, eosinophilic esophagitis, inflammatory bowel, and celiac. And here is another group of diseases. These are autoimmune and metabolic diseases that are linked to gut barrier defect and microbial dysbiosis, diabetes, obesity, fatty liver, autoimmune hepatitis, liver cirrhosis, rheumatoid arthritis, multiple sclerosis, systemic lupus, and ankylosing spondylitis. The third group of diseases are chronic neuropsychiatric conditions. We don't have good models, but when you make biopsies on the right time, you can see that there's enteric inflammation, barrier defect, and microbial dysbiosis is seen. The group of diseases are here: autism spectrum, Parkinson's disease, Alzheimer's disease, stress-related psychiatric disorders, and chronic depression. And the prevalence of these diseases are also increasing nowadays. So we come now to the mechanisms. One of the most important mechanisms is a healthy interaction of the microbiome and epithelial cells is broken. And this homeostatic interaction has an agreement of several hundred million years with the mammalians and with the animals and also with the microbiome. So as humans, for several million years, we are carrying these microbes in our body. And these microbes have a certain job. They have to have digestion, nutrients they have to provide, and vitamins, metabolites, and they have to take a role in education of our immune system, and they have to help the differentiation of epithelial cells and immune system cells, and they have to help the maturation of the tissues. We know this from the germ-free mouse and normal mouse very well, and we can also understand that these are taking place currently. But what happened is that this agreement is broken since 1960s in humans, and the biodiversity of the microbiome and also the number of strains that we are carrying about 1 kilo of microbes in the gut and in our body in total, and there's around 4,000 strains, so which decrease very significantly. And this live together, co-evolve, select, and support reaction is not happening. The first thing that to start when we are exposed to this environmental substances is the epithelitis. And epithelitis is showing together with migration of the microbiome deeper and also translocation of some of the microbiome. At the same time, this irritated epithelium starts to make interleukin-1, interleukin-25, interleukin-33, and TSLP. So TSLP is available now as a treatment modality for asthma. And this increased alarmin production invites the immune system as close as possible, and then inflammation starts. This inflammation is together with neuroimmune interactions, and the activation thresholds of mast cells, dendritic cells, are also regulated. Now remember the expulsion response. What is expulsed? And the second thing, what happens is the expulsion response. So what is expulsed? It is not the parasite larva, but what is expulsed is the microbes that are trying to go in between, touching the epithelial stem cells or translocating below the epithelial cells, should be expulsed. To expulse these microbes, we are showing an immune response, and this immune response is a type 2 response in most cases. And together with it, we have IgE, eosinophilia, T helper 2 cells, ILC2, IL4, IL5, IL13. And at the same time, we have colonization of opportunistic pathogens, mainly for the respiratory area. We are talking about Staph aureus, Moraxella, Haemophilus, and Pneumococcal. And the biodiversity decreases for 3 reasons. The first one is colonizing opportunistic pathogens. The second one is immune response to commensals. And the third one is direct toxicity of environmental substances to commensals. So all of them are taking place. And then there is an autoimmune reaction that's taking place at the same time. And immune response to commensals, mainly to Staph aureus, is becoming very dominant in these patients. So circulating microinflammation is an important concept that you are now learning, maybe hearing for the first time, but this is quite important. Now, if you focus on this section of the lung or on the section of the gut, we see that the epithelial cells are not touching each other, and the microbes are passing through the epithelium, and the cells are activated, and we have now clear evidence that T helper 1 cells coming from the lung and going to brain can cause multiple sclerosis, and T helper 17 cells and T helper 1 cells can go to joint and make rheumatoid arthritis. And there is several evidence for this, like CLA positive skin homing cells from the gut. This was the PhD thesis of Mübeccel, and Donald Deering worked on this area. Impaired gut epithelial barrier before diabetes onset, joint migrating T helper 17 cells, brain migrating T helper 17 cells, they were all reported. Now here's actually a conclusion slide. I would like to discuss with you the epithelial barriers are damaged, and for genetical reasons and exposure to environmental agents, this damage occurs, and colonization of opportunistic pathogens is taking place, translocation of microbiota to subepithelial areas, and immune response to commensals and opportunistic pathogens, and loss of commensals, microbial dysbiosis, and decreased biodiversity is taking place. Then the inflammation of the epithelium and chronicity, that is a chronic expulsion response, is taking place, and defective barrier healing capacity is happening because of epigenetic reasons, so that this barrier can never become a full healthy barrier. So this ends up with 2 billion allergic, autoimmune, and neurodegenerative patients. So if we summarize, we have direct toxicity to epithelium, epithelitis, activation of the epithelitis, release of alarmins, expulsion response, inflammation, and to deep translocated microbiota is taking place. Migration of inflammatory cells to distant organs, so gut inflammation causes chronic hepatitis or brain disease or arthritis, and we have epigenetic regulation. Very strong epigenetic mechanisms play a role in defective barrier healing capacity. So here we come to an important point here to discuss biomarkers. And here I will show you some data for the rapid detection of skin barrier integrity. This is a very nice device which detects skin electric impedance, and this is called electric impedance spectroscopy for the diagnosis of melanoma, skin cancer, and atopic dermatitis. And it is important for treatment follow-up, clinical trial monitoring, early prediction of treatment response in atopic dermatitis, and which is very close to our heart, is to check the babies as soon as possible, and then say that this baby has a damaged skin barrier, should be protected from atopic dermatitis to avoid infantile eczema. And here we can see the devices, and we have here mouse data showing that 100 times or 10,000 times diluted detergents, which are only exposed for 4 hours, are damaging the skin barrier. And we can see here a clinical study showing control skin, healthy skin, showing increased electric impedance score, adjacent tissue, and lesional skin. And the lesional skin shows a fully different levels compared to healthy skin. And we can see here 21 days of treatment, and except one patient, there was full treatment in these patients. And we are also working on EACI guidelines with Yohan Nagachi, Marek Yutel, and we have also EACI working group on epithelial barriers. And I'd like to invite you also to our Congress, EACI Congress in Hamburg, and also EACI Summer Symposium on Epithelial Barriers, which will take place on the 20th of September in Davos. I would like to invite you also to our World Immune Regulation meeting, which we are organizing the 17th time. It will take place in Davos on the 5th of July. And also, again, I would like to remind you the epithelial biology meeting, which will be in Davos on the 20th of September. Both of these meetings will be face-to-face. And I would like to invite you to our new institute. If you haven't seen, just please come and visit, and also, if possible, work with us in the institute in collaborative projects. Now I stop my talk here. Thank you very much for your attention. And I see some questions in the chat. The first question is asking whether there are certain things that in the individual household one can do to avoid this. Yes, there's very clear things that you can do. First of all, packaged food. Stay away from packaged food simply if it has emulsifiers or surfactants in it, and also if the shelf life is more long, because the shelf life of packaged food should be short, and if it includes emulsifiers, surfactants, and preservatives, the shelf life becomes long. This is a simple thing, and stay cooking your own and eating vegetables and legumes and fruits and healthy food. This is one point. Second question is, what can we do for the laundry at home? And for the laundry at home, it is better to stay away from softeners. That's very important, and to decrease the amount of detergent that you are using very significantly. You can use 1/4. You will see that it's enough. That's another important point. For dishwashing at home, it's very important to really rinse appropriately. Check whether your device is appropriately rinsing with enough water, because there's certain dishwasher devices that do not rinse, and stay away from non-rinsing dishwasher detergents that keep the alcoholic oxalate, mainly the shining material, on the dishes. That's very important. For household cleaning, also very important to stay away from sodium lauryl sulfate containing household cleaning. For toothpaste, there's 3% against sodium lauryl sulfate in some toothpaste, but not all. Stay away from anionic surfactants and sodium lauryl sulfate in toothpaste. Try to use toothpaste without these substances. So I thank you very much again. Thank you all the colleagues for this help.